Our last finalist for the evening is enhancing productivity in industries by performing intelligent asset management through sensors and drones. They've even developed a system designed to detect pipeline leakages. Please welcome on stage Daniel Raj David from Team Detect Technologies. Ladies and gentlemen, a huge round of applause for our final finalist for the evening.
Hello, can you hear me? Okay. So hello everyone, I'm Daniel and I'm the CEO of Detect Technologies. What we do at Detect is we build cutting edge technology to do intelligent asset monitoring in the industries. We are born out of the Center for Non-Destructive Evaluation, which is considered one of the best labs in NDT, non-destructive testing, in the world. The team is a mixture of energy and experience. We're all IIT Madras students and alumni. All of us have international experience in NDT, and Professor Krishnan is also considered the father of NDT in India and has won several awards in the same area. So as a founding team, we came together and we decided that we wanted to do something that is going to change how the industries work altogether. So first step was to find a problem, and the problem is corrosion is the reason for loss of 4% of GDP in the world, and pipeline corrosion is a huge part of it. Now, pipeline leaks can have several problems. You have environmental damage, you have productivity loss of the scale of 5 to 15 crores per day in a unit, not even the plant. And worst of all is the case of safety. Now, loss of life cannot be measured in monetary terms. So why this happens today is because currently the sensors that exist today cannot work up to temperatures above 100 degrees, the sensors that monitor pipelines. Whereas what flows in these pipelines is between 250 to 270 degrees. So what the industries do today is they have yearly shutdowns or shutdowns once in 2 years, a 30-day long shutdown, and they build kilometers of scaffoldings, remove all the installation and do point inspections. So they have a man go at every point and do the thickness at that point, check the thickness at that point. So there's a huge opportunity cost associated with it. Now, we at Detect have come up with patented technology for the first sensor in the world that can do online monitoring of these pipelines at high temperatures. It can go till temperatures of around 350 degrees. Up to 5 years of R&D has gone into it from IIT Madras, and we've got all the necessary certifications for installing it in the most dangerous regions in the refinery. How it works is very simple. You have a central power station, you have transmitter receiver, it sends signals throughout the pipeline, not just at one point, and all this data goes to a cloud server and comes to the comfort of your desktop. All that raw data is converted into a pipeline diagram. Now, we built several innovations over this as well. Pulsar coming from here would cost around 20 lakhs with other companies, and we built our own version of a pulsar that will cost just 20K. We have patented the transmitter and receiver, and we built indigenous technology to convert all of that raw data into pipe diagrams. Now, the unique points of the product are one of the very few permanently installed systems in the world. It works till pipelines of 350 degrees. It's incredibly low cost. It's a fraction of the cost of the competition, and all that health, all the data on pipe health is at the comfort of your PC. Over this, you get to do data analytics and figure out what regions of your industry are more prone to leakages and what aren't. Now, we've seen that there's a huge difference between what we do in the lab and what we do in the field. So we partnered up with with Reliance Industries, Reliance Jamnagar, the world's largest refinery. And they have given us space to do all of they in fact put in 60 lakhs of funding to IIT Madras to take it from a small prototype stage to a product stage. And for the first time in 30 years, we have gotten data on a pipeline that was at 280 degrees Celsius. So all the raw data gets converted into a pipe diagram, and here it shows the levels of corrosion that happens. Coming to the market, we've seen that we've taken just the market of high temperature pipelines, although our sensor can be used on low temperature pipelines as well. And we've seen that the total addressable market in the oil and gas industry in India alone comes to about $1.2 billion. If you look at the whole world, it comes to about $68 billion. So if you look at the competition, as I said, we are the only company that can do high temperature permanent long range ultrasonic testing, and we are the only industrial Internet of Things product out there, because there's no other sensor that can sit permanently here. So coming to traction, we were in fact registered only this February 2016. Already we have an intent of purchase from Reliance for 200 sensors that starts from the March. And ongoing trials are with HPCL, BPCL, CPCL, and Gujarat Fluorochemicals. And we've also got interest from British Petroleum and Chevron. We are right now in the seed funding stage. We have an ask of around 4 crores. And out of which 75% would go into capital expenditure and payroll. here's our credentials. We filed both national and US patents, and we have a list of IPs to be filed once the funding comes in. And so far, we have gained a bit of recognition in this time span that we've been working together as a company. These are some of the awards. And I would like to end it with, we started with a small team of 3 guys who really didn't know what to work on. And now we've expanded to a team of around 40 students just doing R&D to save lives in the industry. So I wanted to end it with greatness comes from small beginnings, and our journey is just beginning. Thank you.
Hi, I have a couple of questions.
Sure.
One is, what is the adoption cycle from a customer perspective? How much time do you think it'll take sort of for customers to adopt it? And second question is, when you mentioned the market, you said $1.2 billion in India alone.
Yeah.
Is that an annual market, or is that the total market if you put everything? So.
Sure. So firstly, coming to the first question, the time it takes. So basically, in the start, when it's just a prototype, it's very tough to get into the industries. That's why Reliance coming into the play helped us a lot. But now that we've installed and proven it in Reliance, you saw that the other companies fell into place, CPCL, BPCL. So they just need you to prove it somewhere else, show some live data, and from there on, they will still request for a trial and make it work for around 2 to 3 months. But after that, the orders will come in easily. So with Reliance, we've done the same thing. We are following the same model with the others as well. Sometimes you will need an industry expert, which we have through IIT Madras Research Park's resources, to get into some of these refineries. So that's with respect to the first question. The second question is, now I didn't highlight on our pricing model. So that will make this easier. So basically what we do is we install the sensor, which costs anywhere between 3 lakhs to 10 lakhs, depending on what they want us to install on. And then we charge with the software. So we license the software once a year, per year, per sensor. So this is just for the installation cost. The licensing, right now what we are doing is we are charging it at 10% the installation cost. Because right now the industry is not really used to having a product sitting there and monitoring continuously. But later we are looking at actually changing the model into making the licensing a lot more costlier than that. So this is varying, but this is just on the installation cost.
I have a couple questions.
Sure.
The first, the technology sounds great.
Yeah.
Help us understand, or help us figure out how well does it work. For people who are not, say, in the R&D itself, the ideal metric would have been, okay, here's 10, 15 companies that have used it, here's how, they've stayed with us, and so on, and you're a little bit early. So help us think through the IP a little bit. That's the first question.
Okay, so right now I'll tell you what is done today. Right now the technology used today is called piezoelectricity. That is, electrical vibrations convert into mechanical vibrations. And there are several problems with this. It's not robust and it has a certain temperature range. And one major issue is this data. It requires an NDT professional to come and look at it, and only then they can interpret what the data means. So what we are doing is we're using something called magnetostriction, which is very new in the field of NDT, and we've shown that we have papers proving that it has superior properties. That's number one. Number two is it is just a vibrating magnetic field converted into vibrating mechanical force. So even here, you will need to be trained. So we bring in service engineers. They'll need to be trained for a month to learn how to interpret this data. But nevertheless, here comes our intelligence. So basically, this is the kind of raw data you'll get, except in sinusoidal signals, that to convert into a pipe diagram takes some expertise. So that is also a unique point, that we are building algorithms to convert this easily. And the more data points we get from the industry, the more accurate these algorithms will be. So sometimes we will get false positives at this point, which will need us to review that data. But as we go along, the more data that we get in, it becomes more and more accurate. So that's what we do.
And high temperature sensors are not new. There are quite a few out there, but maybe not
For
your
thickness
kind of,
monitoring,
yeah, exactly.
high temperature sensors do not exist at this point. So high temperature pressure sensors exist, other properties, but when it comes to assessing what the health of the structure is with respect to how much corrosion has happened or if a defect is there, no solution exists today.
I guess we have audience questions.
Yes, so two questions. Can you actually, so you said you have some rate of failure, right? So like what is your rate of failure in terms of like the actual data versus what you're projecting? What is the rate
Sure.
of failure?
Sure. So, let me correct that. By failure also it means that if there is something that comes up in these pipelines, it will be detected. So it will definitely be detected. The only problem is we can get false positives. So false positives is if something comes up but actually nothing has happened to the pipe. So I would say about 4% to 5% of the time you will have rate of failure at this point because we haven't installed it in too many places. But the moment we finish the 200 sensor installation in RIL, then we'll have enough data to actually bring it to 98%, 99% accuracy. So that's where we're going with it.
And you had a pricing that you
I
said
said
like about
it.
20,000 or like how
3 lakhs to
3
around 5
lakhs.
lakhs for installation and 10% to 20% of that for the licensing per year.
So how much is the company saving by installing this?
Oh, perfect. I have a slide for that. Just give me a second. Yeah, there you go. So if you look at how much, so there are, you can classify defects into three different things. So if you have a defect, sometimes they take complete shutdown, or sometimes there's a partial shutdown, sometimes there's no shutdown and just maintenance expenses. So if you have a complete shutdown, you lose around 9 crores to 5 crores. Partial shutdown, you lose about 10 to 20% of this cost. And no shutdown, minimum you lose at least 6 lakhs. So if I take just the minimum case, for 5 years you see that they spend 36 crores in minimum, these plants. Now if they want to avoid that and put in our sensors, all they will need to put is 2.75 crores plus the annual maintenance contract, and they don't have to go to the field to check their pipelines again. All of it will be taken care of. There will be some maintenance costs when our sensor tells you that you're about to face a defect, but that's it. That's the maximum cost they will incur with our system. Sure.
Thank you.
All right, Daniel. Thank you so much.
Yeah,
Ladies
sure.
and gentlemen, a huge round of applause.